Hello everyone, Gaza Mutkash, and I welcome you all to the session on data automation with Python scripts. So guys, let's have a look at the agenda for this session. The agenda for this session includes implementing batch processing operations, where we'll be creating different functions. The first would be to generate synthetic data on a specified use case. Then the second would be to clean, process and transform the data, and even to summarize the data according to the user requirements. And the third would be, let's say, to create let's say a function where we can handle multiple files in a batch, and then we'll be creating another function, let's say, to compile or let's say call all these functions one at a time, right? So far till the previous sessions we have discussed how to create repeatable workflows, and we have also worked with automating file input output. So guys, let's switch to the Jupyter screen. So guys, currently we are in the Jupyter screen. So guys, let's understand what do we imply by batch processing operations, right? So when we talk about batch operations, to implement this using NumPy and Pandas, batch operations in Pandas and NumPy refer to performing vectorized computations or transformations across multiple batches or let's say records, files, datasets in a single pass or loop, rather than implementing it row by row manually. All right. For example, suppose we do get daily stock data. All right. So we do have a batch of files that do get accumulated over a week. If you want to, let's say, apply some cleaning, transformation, or generate an analysis or summary report, so this is where batch operations or batch, let's say, processing comes into picture. So what are the benefits of, let's say, creating modular functions that facilitate these batch operations? The benefits include scalability. So using these batch operations, we can handle even functionalities that cater to large data sets. Speed, right? Because we'll be utilizing NumPy, so speed, let's say, increases manifold times. Then we have repeatability, right? So same logic can be applied to multiple batches of data, provided the structure of the file remains the same. So in batch processing system, the only limitation is that the structure of the file should remain constant. Otherwise, maybe what we can do, maybe we can write multiple if else scenarios that do handle, let's say, different, that caters to different types of files. And accordingly, the data cleaning, transformation, and summarization would also change. So guys, now having understood what batch operations typically implies, let's proceed to the use case that will be working in this session. So over here, the use case is going to be sensor data aggregation. Let's understand this. The problem statement over here is, suppose you work with some IoT temperature sensors in different rooms of a factory. All right, IoT is Internet of Things. Now each day, each sensor logs temperature data into the CSV files. So because we do have a sensor that logs the temperature at different timestamps on different days. All right, so we do receive daily sensor data containing, so we do have the timestamp, then we do have the sensor ID, and then the temperature. All right, now the three, let's say, columns or the features that we have, this is for a particular day, this is for one particular day, or maybe let's say for across a week. So we can have some let's say date time denomination, right, according to which we can have this timestamp, the sensor ID, and the temperature. So इसके बाद हमें क्या करना है? What are the requirements of the objective? The requirements or objective include to read daily sensor files in a batch, and then clean the anomalies. For there can be certain let's say sensor data glitches, we have to clean them. Then we have to compute daily summary per sensor, and then save all daily summaries into some master report. So over here we have to handle the entire batch of sensor data, right? So this is where batch processing comes into picture. So guys, let's proceed with this. So इसके implementation के लिए what can be done? First of all, I'm importing pandas. All right, then I'm importing NumPy, then OS. I'm also importing datetime. I guess counter is not required, and even regex is not required, right? So I've imported pandas, that is essentially we'll be using for data cleaning, transformation, and data reading as well. NumPy will be using for mathematical computations. OS, let's say, for file saving, all right, for file input output, and date time just to handle the date time data. Now the first step would be to, let's say, set up the folders. So over here I'm setting data directory where I'm calling the sensor data, and the summary directory I'm calling it sensor summaries. So if I show you over here, Right now we don't have any sensor data and summary sensor summary folders over here, correct? So when I execute this line of code, so the data directory will be created as a folder. This os.makeDirs is basically making a directory, right? So what are we implementing over here? Make a directory with the name of data directory. All right, now over here again we are making a directory with the name of summary directory. Now exist OK is equal to true means only if the folder does not exist then create it. If the folder is pre-existing, it won't be created, right? So let's execute this. So this functionality, let's say, ends up creating two folders. So guys, clearly we can see that we do have two folders, sensor data and sensor summaries. Now once this is done, let's proceed to the second functionality, which is to generate sample batch sensor files. Now what is the objective of the second step? Over here we need to create a function that takes number of days, number of sensors and readings per day. For each day, how many sensors do we want, how many days of data do we need to process in the batch, and let's say the number of readings that I need to generate per day. All right, so I need to pass these parameters as arguments and add the following functionalities. So जो हम यहाँ पे function बनाएंगे, that will take three parameters: number of days, number of sensors and readings per day. Now we have to generate synthetic timestamp, sensor ID, temperature data for different dates for different sensors. So what are the three features? We have timestamp, sensor ID and temperature data for different dates for different sensors. Now we have to inject some errors. That is where data cleaning and transformation will come into picture. Now, besides this, we have to save the file to a specified path. All right. So over here, the table that we have is sensor, means we'll have some table of sensor format where the features are timestamp, sensor ID and temperature. And this is how the file name would look like: sensor underscore sensor ID, and then we'll pass the date on which this for the sensor ID the file was saved. This is what we need to let's say save. This is how we have to save the file. All right, so save the specified save file to a specified path in a custom format. All right, this is the format suppose we'll be using. So let's have a look at the example. So over here I'm creating the function called generate sensor files. The number of days that I'm considering is 5, the number of sensors is 3, and the readings per day is 24. So assuming, let's say, one reading for 24 hours, one reading for each hour. So for 5 days of data for 3 sensors, we are reading 24 readings. Now np.random.seed, this is used to generate some randomness. Base date is today's date. Now for day in range number of days, how many days do we have? We do have 5 days. So day value ranges from 0, 1, 2, 3, 4. Now the current date would be base date, which is today, minus time delta days is equal to day, and then this is some string formatting, right? This is some string formatting. So let's have a look. If this is what I'm passing, and what is my base date? Base date is today's date, right? Base date is today's date, and day, suppose if I pass as 0. So what is the current date? The date on which the file will be created, right? So this is 2025-05-24. If I make it 1, it will be 23. If I make it 2, it will be 22. Likewise, if I make it 3, it will be 21. So this is how the current date changes based on the day on which we are, let's say, generating the synthetic data for the sensors. Then for sensor ID in range, now how many sensors do we have? We have 3 sensors. So for sensor ID in the range 1 to number of sensors plus 1. So sensor ID would start from 1 all the way up to number of sensors. All right, so the sensor ID would be 1, 2 and 3. This would be the sensor ID. Now over here I'm creating some random temperatures. So this would be np.random.normal. So I'm fetching the data from some normal distribution, right? The location is 22. LOC is the, let's say, mean. The scale is 3, that is the standard deviation, and size is readings per day. How many random normal values do we need? We need 24 random normal values for each day. Now we are injecting certain errors. So if random.rand, if let's say if this random number generates a value greater than 0.5, then over here I'm passing some data, np.random.rand integer 0 to readings per day. Now over here I'm injecting some temperatures like this. some random value between 99 and minus 10. Alright, I'm injecting some random value between 99 and minus 10. So these are certain glitches that we need to deal with. Alright, so these are the glitches that we'll be dealing with. Now over here I'm creating a data frame. The first feature that I'm using is timestamp. How are we populating the timestamp values? So pd.date range start is current date, that would be the date that we have over here, and then 00 for hours and minutes, and periods would be readings per day. So date range means considering the current date and the time. The periods would be readings per day, frequency is hours, so it will increase for every hour. So this means this would be 0000, then 0100, 0200, and so on, because date would remain same, only the hours would change. Then the sensor ID would be this sensor ID that we are generating, so it would range from 1 to 3, and the temperature would be generated from this temperature with, of course, some glitches. Alright, with some glitches, these temperatures, this temperature data would be populated over here. So now we do have the data frame ready. So once the data frame is ready, I'm creating the file name like this. This is the variable sensor, that is a string, underscore sensor ID. So for the first sensor it would be 1, then current date, let's say for day is equal to 0, the current date would be 20250524. Alright, and .csv, this is the file name. Then I'm using this df.tocsv, this data frame is created. I'm using the tocsv function, and I'll be saving it in os.path.join data directory.file name. Alright, so let's understand this. os.path.join. So os.path.join data directory we have seen, and the file name I'll show you. For example, this is the file name, right? If this is my file name, I'm calling it fn file name. If this is the file name, sensor ID is maybe 0 or let's say 1, and the current date is, I'll pass this. Alright, so this is my file name, and we know what is my data directory. The data directory is sensor data. So this is the os.path, this is fn. So guys, if you observe, this is the path onto which this file will be saved. So to save it, what I need to implement, I need to write df.tocsv. This is the path at which will be saved, but I don't want any indexes, so I'm setting the index to false. And then over here I'm printing generated this particular file name. So guys, this is how, let's say, the file is going to get generated. So this function generate sensor files is essentially generating, let's say, 24 readings per day for 3 sensors for 5 different days, with some glitches in the data, and the file is saved in this folder, and the folder name is sensor data. So currently I've just let's say executed the function, I haven't called the function. The second let's say the second process over here is to process a single sensor file. So how do we process it? Over here the objective is to create a function that takes file path as argument, and we have to add the following functionalities. What are the functionalities? We have to read the file, we have to convert date to date time, then we have to clean the out of range anomalies, then we have to generate sensor summary status. Alright, next we have to generate sensor summary stats, then we can return from this function the summary stats, right? So over here I'm calling the function as clean and summarize sensor file. The first step is to read the file. Alright, this is the first step. Then I'm fetching the sensor ID. The second step is to fetch the sensor ID. The third step is to convert date to date time. Alright, in the third step we are converting the date to the date time. In the fourth step we are cleaning out of range anomalies. So how do we fetch the sensor ID? Df sensor ID dot ilog0. How are we reading the file? pd.read csv file path. I'm storing the file in df. So from the df I'm reading the sensor ID dot ilog0. So value present at index 0. Then how to convert date to date time? For this I'm using the pd.toDateTime function. Alright, and then I'm passing df.timestamp.ilog0.date. So it's only the, let's say, 0th index value that I'm converting it to date, and I'm storing it in a variable called date. Then we have to clean out of range anomalies. The anomalies were generated in the temperature, right? So we have to clean the temperature. So df temperature np.where df temperature, if the temperature is less than 5, or if the temperature is greater than 50, then I'm filling it with null values. Alright, then I'm filling it with null values, otherwise I'll retain the value of the temperature. So this is the lower limit, this is the upper limit that we are capping the temperatures to, because this is the normal range of temperatures that we are expecting the sensor to let's say vary between. This is the ideal variance that we are expecting from the sensor. Now you can change this values according to sensor of your choice, or maybe we can have certain customized sensors as well. Now to compute the summary stats, first of all, for each sensor ID I'm capturing the sensor ID. So I've created a dictionary where the key is sensor ID, the value is also sensor ID. The date is the date that I'm fetching from the pd.toDate timestamp, and then I'm converting it to date. Then the readings would be df temperature dot count. How many total readings do we have for each day? So that is what I'm counting. Then I'm counting the mean temperature. So mean temperature would be temperature dot mean. I'm rounding it off up to 2 digits. Then the minimum temperature. So again, I've computed the minimum of the temperature rounded to 2 digits. Then the maximum temperature. Over here, I'm let's say computing the maximum temperature, rounding it off to 2 digits. And then I'm computing the standard deviation of the temperature, rounding it off to 2 digits. So this is the general summary, right? So essentially what we are computing count, then mean, then we are computing the minimum, then I'm computing the maximum, then I'm computing the standard deviation, right? So this is the summary stats, and then I'm simply returning the summary. We can save this data to a data frame as well. Alright, because we do have a dictionary, we can convert this to a data frame as well. So this will be recorded for each and every summary, for each and every sensor. Are you getting this? We are capturing this summary for a particular sensor ID. But how many sensors do we have in total? We have 3 sensors. So the objective over here is to apply this function to the batch of sensor files that we have. Not just to one sensor, but to all the sensors that we may have. Alright. So guys, these are the 5 steps that we have implemented, and then basically this is the 6th step where I'm returning the summary stats. Alright, so let's execute this function. So this function has been executed. Next, over here, what do we have? We have to apply the batch processing function. The 3rd step is batch processing function, where I need to create a function that takes file path as argument and add the following functionalities. We have to iterate through all the files from the input directory, then apply the clean and summarize sensor function to each of these files. Alright, we have to apply the clean and summarize sensor to each of these files. Then we have to save the summary to the output path, and then we have to return the sensor summary. So essentially this is the function that let's say is the core objective of this session, where we need to batch process multiple files, right? So over here I'm creating a function called batch process all sensors. I've considered a list. All right, so this is list of summaries. So this was comprised of list of summaries for of all sensors. Currently it is empty because when I'm defining it, I don't have data to begin with. Now for file in os.list directory, data directory. So if you observe, in the data directory, we'll be having multiple files. Why? Because this function would have been executed, all right, which is generating sensor data for n number of sensors. Now, once this is done, if file dot ends with CSV. So what is file? File is the file name, right? This is the file name, this variable over here. So each of these files is ending with .csv. So what is the path? os.path.join, the data directory and the file. All right, and then I'm applying the clean and summarize sensor file, all right, to this path. Path contains the entire file name. All right, path would be the entire file name along with folder name as well, right, along with the folder name. Then this is where I'm summarizing it, clean and summarize sensor file and the path. Then over here I'm passing summaries.append and then summary. So what is the summary that I'm passing over here? The summaries that we have over here is, this is the list into which I'm appending this summary. Then what do we have as the summary df? The summary df would be pd.dataframe summaries. So all the summaries, because this is a list and I'm passing this list to a data frame, so this would end up creating the summary df output. Now I need to create the output path, that would be os.path.join summary directory, that is our output path, then followed by sensor daily summary datetime.now. All right, then strf time, this is used to format the data into a custom datetime format. So the format used over here is year month date then underscore hour minute seconds dot csv. So this is the format of the sensor daily summary datetime. Datetime would be in this format, right? And the file name would end with csv. Then summary df to csv. So I'm saving this file to the output path which I have established over here. Indexes false, I don't want to have any indexes as far as let's say this data is concerned, right? Then over here I'm simply printing the batch summary is saved to the output path, and then over here I can return the summary df. Over here I'm simply returning the summary df. All right, so the summary df is a data frame. When I'm returning the summary df, this is a data frame. So when I'm applying batch process all sensors, and if it is returning a data frame, so I need to have a mechanism to capture it. All right, wherever we are returning the data frame, we have to capture it, because when we are clean and summarize sensor file, this is returning a dictionary, right? Which is a dictionary. So where are we capturing this dictionary? This dictionary is captured in the summary. All right, so what is summary? Summary is a dictionary over here. All right, and then when I'm appending it to a list, so what does this list become? This is a, so it is a list of dictionary, right? It is a list of dictionaries. It is a list of dictionaries. All right, then over here we do have summary df pd.data frame summaries. So this summary df is a data frame. All right, यहाँ पे हमारे पास एक data frame है, and then finally I'm returning the summary df, right? So this is the batch process all sensors, but now we have to call all these functions one by one. All right, and accordingly we'll obtain the output. So we have to call above created functions inside the main function. This is the fourth step. So the objective is to create a main function, then call the generate sensor files function, and then call the batch process all sensors function. So when we are calling generate sensor file functions, so this is essentially returning the data frame, right? This is returning the data frame. Now whatever the data frame is returned, see, it is this one, the first function is not returning anything. It is simply, let's say, saving the file to some csv path, right? Now the clean and summarize is already taking the file, and then this is returning the summary, and then the batch process is returning the data frame. So over here, first of all I'm generating the data, then the batch process will automatically take care of calling this function clean and summarize sensor file, because this is where we are implementing it. Clean and summarize sensor file is where we are implementing it, and the rest of the things have been taken care of by this batch process all sensors function. So what is the next step? I'm simply returning the summary df, and the summary df is returned over here, and this main function is also returning summary df. So let's call the function. Currently we have executed this function. Now I need to call the main function, right? So over here I'm writing, this is summary df, and then I'm writing, let's say main, I'm calling the main function. So guys, as we can see, the moment we have called the main function, because the batch process all sensors would generate the output path, each and every output path would be generated over here. So just observe how many output paths are we generating. For each sensors we have 3 days of data, right? So just observe, for sensor 1 we have data from 2025 05 24, for sensor 2 05 24, for sensor 3 05 24, then again for sensor 1 05 23 05 23 05 23 for 1 2 3, then again for sensor 1 2 3 we have dates from 05 22 05 22 05 22, then next for sensor 1 2 3 we have dates from 05 21, and then for sensor 1 2 3 we have dates 05 20. All right, so means in a total of 15 files are generated. In a total of 15 files are generated for 5 days for 3 sensors. All right, and each of these files contain 24 readings. So this is the data that is generated. Now it says batch summary saved to sensor summary sensor daily summaries into this file. All right, and now if I display the summary df, So guys, just observe the summary DF is having this. This is the sensor ID, then this is the date, these are the readings, this is the mean temperature, minimum temperature, maximum temperature, and standard deviation of the temperature. Now from this summary DF, if I observe the sensor ID, how many unique values does it have? So clearly we can see that it has three sensors, right? It has three sensors. What are the unique dates that we have? So this is summary DF, date dot value counts. How many unique dates do we have? So clearly we do have 5 dates, 20, 21, 22, 23 and 24. And these are the readings. How many readings have we taken for each day? Now wherever we see 23 or number less than 24, because that's the reason, because we have cleaned certain glitches, right? We have dealt with couple of anomalies. So guys, this is the entire summary. Now I'll also show you the folders where the data is stored. So if you observe the sensor data folder, clearly we do have these files, right? So for ID1 we have these three files, in fact 5 files, all right, for each ID. Then for ID2 again 5 files, then ID3 again we have these 5 files. So this is the data I can show you. I'll open this and I'll show you these are the 24 readings. Likewise, if we go to let's say sensor summaries, so this is the entire summary, right? This is the entire summary that we have. So we can also look at the shape. What is the shape of the summary DF? So guys, if you look at the shape, we have 15 rows and 7 columns, right? So for each of the sensors, means for each sensor, let's say we have 5 records. All right, why 5 records? Because there were a total of 5 days of data. And how many sensors do we have? We have 3 sensors, right? And how many readings per sensor do we have? We have 24 readings. And for each of these 24 readings, we have applied this summarization. So guys, as we can see, we have successfully implemented the batch processing system for the sensor data use case. So guys, that brings us to the end of this session. So let's switch to the PPT. So guys, in this session, we have understood how to batch process files using NumPy and Pandas, and the case study that we have discussed is sensor data generation, cleaning and transformation, and then applying batch processing onto them. So guys, in the next session, we'll be looking at, let's say, understanding repeatable workflows using the looped tasks. All right. Thank you.